Okay, so we are live. Good afternoon, good evening, good morning to whichever part of your world are, and welcome to today's live session on Deep Convolution GANs and TensorFlow, which is presented by Nitin Tiwari. Nitin Tiwari is a Google engineer, he's a software engineer at LTI Mindtree, and is a Google developer expert in ML. So throughout the session, Nitin will take us through implementation of DCGANs, about its working, and then later he'll get into the hands-on session on how you can implement DCGAN with TensorFlow. So without further ado, let's welcome Nitin and we'll start with this session.
Thanks for the introduction, Tarun. A very good afternoon for to one and all. My name is Nitin Tiwari. So I'll just give my quick introduction. I am a software engineer at LTI Mindtree and a Google developer expert in machine learning. So I've been, working with machine learning from the last 2 years. I've been working with TensorFlow and computer vision. And yeah, today is just one more day that I have the opportunity to share my knowledge with the community. And I welcome you all to this session. So I'll share my screen. All right. So this session is all about DC GANs. So for those of you who have just started your, journey in machine learning, you might have come across this term called as computer vision, right? So DC GANs is nothing but it's type of neural network that deals with what do you say? That deals with generative AI. Okay. So welcome to this session on DC GANs unleashing creativity with TensorFlow. So let's quickly have a walkthrough of what is going to be covered in this session. So we'll be talking about introduction to GANs. Okay, we'll see what exactly GANs are, followed by the DC GANs on which the topic is scheduled today. So we'll try to understand what are deep convolutional GANs. Next, we'll see how we can implement DC GANs with TensorFlow. Okay, so we'll be doing a hands-on practical lab on DC GANs with the help of TensorFlow. And then finally, at the fag end of the session, we'll try to see some interesting examples that are built with TensorFlow. So the fourth subtopic in this content, as you can see, it's not directly related with GANs, but we'll see what exactly you can build with TensorFlow. So I hope you all are excited for this session, and I think we can begin. So before I start, it's a question to all the attendees. You know, can you just ping in the chat what is your understanding about GANs? What do you understand with generative adversarial networks? Have you heard about this term anytime before? If yes, then you can just put your understanding about it. If no, then also you can just put your message, and then I will share my knowledge about this. So getting quite a lot of comments. Okay, so we'll start with the introduction to GANs. So GANs are nothing but these are the generative adversarial networks, also known as GANs. Okay, so these are nothing but the generative machine learning models which are used to generate new artificial data that resembles the training data. So if you have already started your journey in ML, you might have come across these terms called as training data, test data, then the models that we train. So GANs are nothing but when we train a model without labeling the data. Okay, so that comes under unsupervised learning. So what in this case is happening is GANs are trying to generate artificial data with the data that we provide to the computers. Okay, so if I were to break down this whole term generative adversarial networks, let's try to understand this one by one. So when we talk about generative, this is nothing but the computer itself generates new data. Okay, next is adversarial. So adversarial is nothing but unlike other models, the old models that we used to train. In those cases, what used to happen is we used to train only one single model. But in case of GANs, we are training multiple models simultaneously. So there is a kind of competition happening between these two models. So competition is just another word for adversarial. Okay, so some kind of competition is happening between these two models, so that's why we call it as adversarial. And of course we are training a neural network, a deep neural network, and hence the whole term is referred to as GANs, generative adversarial networks. So these GANs were introduced back in 2014 by Ian Goodfellow and his team. Okay, so if you Google about this person on on Google, if you see about this, then you will get a lot of papers. Okay, so you can read about that also. But I will give you a basic gist of this. So as I said, unlike traditional neural networks, GANs are ML models that consist of two neural networks. Okay, so one of them is called as the generator, and the second one, the counterpart of the generator, is called as the discriminator. So we'll try to understand the functionality of each of these neural networks one by one. So generator, what it does is it generates or creates fake images from noise and then passes them to the discriminator. So I'll try to keep this as simple as possible for you so that you can also understand every bit of the session. So it's pretty simple, right? Generator, as you can imagine, it generates something. So in this case, it will generate fake images from noise and then it will pass to the discriminator. And what will the discriminator do? It will examine the images which were created by generator in the previous step. Okay, and then it will discriminate whether these images are real or fake. So the job of the discriminator is to categorize or classify the images generated by generator and help us find out whether these images were real or fake. So this is the basic understanding or basic functioning of GANs. Now let me visualize this whole term. So if you see in this image, you can see there is a generator in the first row and there is a discriminator below the generators. So what do the machines do in the back end? So we as humans, okay, if let's say if I am a 4-year-old kid and I'm just learning to read out alphabets and characters and numerals, all those things. So just like we as humans learn, machines also tend to learn from the data that we provide to them. So if you see the first image, if you see there is a scribble in the very first image on this slide. So what is the generator doing is it's trying to generate something that it knows, okay, from a noise. It's a random noise. You won't find any data in this image, the first one. So after many attempts, you know the generator tries to draw more meaningful data out of it. Okay, so if you compare the first image with the second one, you will see some resemblance of cat, right? It's a shape of a cat, something like that. So we are able to imagine what the computer is trying to deduce in this case. And then finally, if you see after many attempts, the computer is able to generate a complete image of a cat. So we as a humans can easily distinguish that, yeah, this is a cat, the third image is a cat, and the second one looks like a cat, and the first one is just complete random noise. So this is the task of a generator. And simultaneously what the discriminator do is it will take the input from the generator. Okay, so the first image is a scribble, we won't find anything from that. And the discriminator is easily able to find out, yeah, this is a fake image, this nowhere is related to a cat. So it will reject that image, it will ignore that. So again, as you can see in the second image, it looks like a cat, but it isn't a cat, right? It's not a real image of a cat. So it will again reject it. But at some time, at some point in the future, okay, there is a saturation point where the discriminator is not able to categorize whether this image is fake or real. So even if the generator tries to generate a fake image, the discriminator won't be able to distinguish that. And in that case it will consider a fake image as a real image. So in that case the generator wins and the discriminator loses. That's why we call it as a adversarial network. Okay, there is a competition happening between these two models. So we'll see how does this happen. Okay, of course there is a mathematics behind all this because machine learning is all about maths at the end. So we'll see what exactly is needed to build something similar to this. I hope your understanding about GANs is clear, like the basic operations of GANs. Now we'll see. I have activity for you as well. So I want you all to visit this link. Okay, https this hyphen person hyphen does not exist.com, and I want to try you all to try something from this website. I'll do one thing. I'll also open this from my end. So the link was this person. does not exist but com/en. Okay, so yeah, so this is a website. Okay, this is an application created by someone, and it generates fake random images from the data that we provide. So if you see, we have certain options here. We can select the gender of the person that we want to, create an image. I'll choose male. Then the age you can give, ethnicity. So these are just the parameters that we are giving to the computer so that it can generate images based on this, inputs. If I just give Indian and then just I refresh, so you can see that like this is an image which is generated by computer. This person in the image does not exist at all in reality. So these all are, created using GANs. These are fake images. So today we'll be doing something similar, okay, but not at this scale. You can see that we as humans will not be able to distinguish if this person is fake or real, okay, if someone shows this image to us randomly. So we'll try to do something similar, okay, with TensorFlow. We'll be, building a DCGAN model that will be able to create fake person images. Okay. So again, this was one more image that I had generated, and this doesn't exist at all. So this was just to give you an idea about what GANs are capable of doing. In the era of generative AI, a lot of things have, drifted towards, generating images, generating texts. You might have heard about Chat GPT as well. So it's important to understand the, how things have been changed in the recent times. Now let's move on to the next subtopic. So let's try to understand what are deep convolutional GANs. So far we have talked about GANs, we have the basic understanding, but what is DC GANs? So DC GANs is just a type of, generative adversarial network, okay, which is focused based, mostly on images. So when we talk about GANs, it's just not, limited to images. It is also, it also involves text files, then it also involves other type of data. But DC GANs is specifically about images and videos, okay. So let's try to understand the architecture behind DC GANs. So if you read the original paper, okay, which was published by Ian Goodfellow and his team, then you will see that this is an input, okay, this is a neural network, and we are supplying an input called as 100Z. So 100Z is nothing but a noise of vector size 100 cross 1. Okay, so we start with a random noise of 100 cross 1, followed by, you can see a multiple layers, right? You can see 1, 2, 3 and 4 boxes between the first layer and the last layer. So these are nothing but some, middle layers, you can say the hidden layers, okay. So what we are doing is we are converting the 1D noise to 3D, three-dimensional, okay, and we reshape it to 1024 cross 4 cross 4. So how do we know that this is one dimensional and this is 3D? So if you see, this is a vector 100 cross 1, okay, and if you see, we reshape it as 1024 cross 4 cross 4. So we can see that there are three dimensions in this case, okay. So we, continuously deconvolute this from one layer to another layer. You can see that the size is decreasing from 1024, then 512. So it is halving at every stage until it reaches 128 and then finally 64. So it will continue to deconvolute until the size becomes 64 cross 64 cross 3. But what are these numbers here actually? So when we talk about, in terms of non-technicality, 64 and 64 is nothing but the height and width of the image, okay. So whatever the output will be generated by this generator, it's an image of 64 cross 64 size, and the three here resembles the RGB channels, the red, green and blue, of course. So RGB channels means the final image will be a colored image. So we started here from 100 cross 1, then we went to the next layer as 1024 cross 4 cross 4. Then at each layer, at each subsequent layer, you can see the size decreases here. It goes on from 1024 to 512 and then 256, 128 and then finally 64. So why only these numbers? It could have been something else as well, right? So these numbers have been, taken from the original paper, from the original implementation of DC GANs. So for that reason, I have just taken this as an example. Okay, so we have talked about generator, right? Earlier when I was talking about GANs, we talked about there were two models. There's one generator and there's one discriminator. So this is just the 50% of DCGAN. This is the generator, but when you see, there is a job of discriminator as well. So discriminator, what it will do is it will take the output of the generator. Okay, I will go back to the previous slide. You can see that this 64 cross 64 cross 3, this the final layer, this is taken as an input for the discriminator. Okay, and it will convolute now. So in the previous case, it was deconvoluting. So deconvoluting is nothing but the opposite of convolution. Okay, so we'll try to understand what this convolution and deconvolution is in when we doing this implementation in TensorFlow. We'll be doing the actual coding in this case. So convolution happens until the final layer of discriminator, which is nothing but a sigmoid function. So I may be talking about in terms of mathematics. Okay, so if you are not aware of what exactly is a sigmoid function, you can just Google about it. So I'll just give you a gist of what exactly is a sigmoid function in in rough terms. So if you give some input to a mathematical equation, and if you are getting some output that ranges between 0 and 1, so that is nothing but a sigmoid function. Okay, and we'll see what is the use of this 0 and 1 in the later stages of this session. Okay. So once the convolution happens, the discriminator, what it does is it decides whether the image is fake or real. So as I said in the previous point, it's a sigmoid function. It will give values between 0 and 1. 0 is nothing but fake, okay, and 1 is nothing but real. So anything that lies between 0 and 1, that depends whether the image is tending towards a fake image or it is a real image. So if it is zero point 0.5 exactly between 0 and 1, then you can say the discriminator and the generator both are in equilibrium. So in that case, the model gets confused whether this image which was generated by the generator, is it a real or a fake image. Anything between 0 and 0 0.5, that is towards the fake side, right? That's towards the left hand side. So the discriminator will understand it as a fake image, and anything between 0 0.5 to 1, so it will try to deduce that image as a real image. So if the percentage is exactly 1.0, then the discriminator will not be able to classify it as a real or a fake image. It will consider even the fake image as a real image. So this is the duty of a discriminator. If I were to just merge these two together in a single image, this is what exactly DCGAN does. It will take the input, it will deconvolute till it obtains this layer, and then this will be given as a output. Okay, this output will be given as an input to the discriminator until it reaches the final point in this case, which is the value between 0 and 1. So I think we are good to start with the implementation. Okay, I'll share my screen and you can follow along with me. So just to give you a gist of what we are going to do, we'll be training a DCGAN model with Keras and TensorFlow. And you can see, right? So from the GIF, you can see. So we start with a random noise. You can see the images are being built by the computer. Okay, the model is trying to generate some images, and as we proceed with each epoch, you can see there is a consistency in the images built by the model. Some images look like real. I won't say real, but they look like real, and some images are of course they look fake to our eyes. So we'll try to implement this in TensorFlow. So what you can do is you can just open Google and log into your Google account and open Google Colab. I'll go to my GitHub repository. I'll copy this link. So if you have already installed Git on your local machine, then you can just click on this green code button and you can just click on this copy code. Okay, so it will copy the URL of this particular repository. And if you don't have this Git installed on your machine, then you can just click on this download zip. So it will download the complete zip file of this repo. So since I already have Git installed, I'll just clone this repository on my desktop. So I already have this repo, so in that case it will not clone again. Once you have downloaded this repository, or once you have cloned this repo, then you will see that there are 3 files in this repository. You can ignore this readme. So we'll see there is a IPYNB file. It's a Jupyter notebook file. Then it's a DCGAN GIF file that is produced as an output, and there is a generated folder as well. So you can ignore this as well for now. So we are just concerned with this particular file for now. Okay. So I'll go back to Colab. I'll click on File, Upload Notebook, choose File from my desktop, and this is the file here. Okay, so once the notebook is loaded, you can click on Connect here. So it will connect to this Jupyter notebook. Now, one more check we have to do is before we start running this cells. First of all, we have to see whether the runtime is connected to a GPU or not. So if you click on runtime and see, then this should be GPU. The hardware accelerator should be set to GPU, and this GPU type is T4 by default. If it is none or TPU for some reason, then you can just select this GPU and click on save. So it will again reconnect to the session. All right, so we are connected and we are good to go. So the first step is to import all the libraries that we are going to use in this implementation. So we'll need NumPy, OS, Matplotlib, and so on, all these libraries along with TensorFlow, Keras, and we need some few more libraries as well. Like for example, this optimizers that we'll be going to use to train the model, then the loss functions, and so on. So let's start with this. We can just straight away click on this cell. So once the libraries have been loaded, it will just give a green tick here, just for our understanding. Now the next step is to install the Kaggle API. So this is not really necessary, but since I'm getting the data set from Kaggle, okay, I'll be using the Kaggle API. And just for your understanding, we are going to train this model on the celeb A dataset. So celeb is nothing but it's a data set of some celebrities. You can see the faces of some celebrities. This A stands for attribute. So basically, we are going to train our model on this particular data set. So I'll run this cell to install Kaggle API. And by the way, if you don't have your account created on Kaggle, then you can also skip this step. But in that case, you will need to upload the dataset manually. So it's always suggested that you create an account on Kaggle. Of course, if you're learning machine learning, then it's obvious that you have a Kaggle account. So it's always recommended to have it. Now we need to set the credentials. So I'll give my credentials here. I'll stop sharing for some time. I'll give the credentials. Okay, so I've reshared my screen. Now the next step is to download the dataset. So it's about 1.32 GB in size, and it consists about more than 2 lakh images. Of course, we are not going to train it on such a big data set. So what we'll do is we'll just modify this original data set. Otherwise, it will take a lot of time. So it takes some time to download the data set and then unzip it. As you can see, it was a zip file of size 1.32 or 1.33 GB. And if you unzip that, then of course the size will increase as it contains about more than 2 lakh images. Okay, so once the file has been unzipped, you can see that there is a folder called as img underscore align underscore celeb a. Okay, so in this folder, you can see there is another subfolder, and within that folder, we'll get all the images. So what we'll do is we'll set a base directory, okay, that has all these images. As you can see, this is content, and within content we have this folder, and within that folder we have this subfolder. So the first step is to get the path of all the images. Okay, there are about 2 lakh images in this. So I'll run this cell. Okay, now you can see the length of this, image paths. This array, it has about 2 lakh 2,599 images in this. Okay, so I'll just open YouTube as well to see some comments from some users. I'll again stop sharing.
Okay. So I'll be adding few questions.
Yeah, sure.
Which framework works better for GANs, TensorFlow or PyTorch? I am currently learning PyTorch. Any suggestions?
Well, that depends upon, there is not a straightforward answer for that. Whatever suits the best for you. So normally I use TensorFlow. I prefer that because it makes the job of deployment easier for me. And it's pretty, you can, decide on the framework once you have the knowledge about that, like your experience says about that. So there is no straightforward answer to that according to me.
So the next question is, how does transfer learning play a role in DCGANs? And can you give an example of how it has been used in practice?
Okay, so when we use transfer learning in case of DC GANs, it makes our job of training the model easier. We don't have to train it right from scratch. First of all, we already have the weights for a pre-trained model, so we can just modify the output layers. Okay, we can unlock those layers and then we can retrain our model on any custom data set. So that is one of the advantages of using transfer learning in DC GANs. And when we talk about this in practice, so as you can see, there was a application, okay, where they were used to create real images out of the fake data set given. So it makes your job easier in any field you can consider about that.
Okay, so I guess there are no more questions. And
Okay.
in beginning, when you asked that if there is any people who know about GANs, in previous session also we had about generative AI with using GANs and stable diffusion. So these are few comments regarding that.
Okay, so deepfakes are nothing but, yeah, so deepfakes are based on this GANs as well, where they used to create fake images of celebrities as well. You can consider this as the base point, the celebrity data set. And yeah, that is the point here in this case.
Okay,
So
so the
let's
next
move
question is, which
on.
loss function do we use in GAN?
So there is a two loss function in this case when we talk about the this discriminator. So in this discriminator we make use of the sigmoid function, okay, that is used to find out the output layer, okay. So that determines whether this is a real or fake image.
So I guess it will be binary cross entropy.
Binary cross interval,
Since
right?
when, okay.
Now let's move on. I'll reshare my screen. Hopefully my screen is visible. Okay, so let's move on. Now we were at this stage, okay, the length of the image paths was 2,02,599. So we had this much of images, but we don't need these images, right? We'll be training our model on a smaller subset. So what we'll do is, it's more of a Python in this case. It's more of manipulating the data that we have. So I have created a variable called as images delete. So what it will do is, it will delete the last 1,80,000 images from the original data set. So I'll run this cell, okay, and after deleting these images, it will append the remaining images in this image path. So this array now will have only 22,600 or 599 images. Okay, so we have deleted the rest of the 1,80,000 images in this. Now the next step is, we have the data set with us. We'll be training our model on this smaller subset. Okay, I'll just refresh this pane at the left hand side. And the next step is to create a new directory called as resized. So what I have done is, I've run this cell. It will create a new empty directory. Okay, we don't have anything in this case. Now whatever images we had after deleting these number of images, will be first resizing it to 64 cross 64. So as we had seen in the slides, that we had the final uh, image, the size was 64 cross 64. So that's the reason we need to resize it. Okay, so it will open all the images. It will then resize it to 64 cross 64, and then it will resave it in a new folder that we had created in the previous step, in this resized folder. So it takes some time because it has to open all those 22,000 images. Okay, so I think the cell has run successfully. We'll just expand this resized folder. Since it has 22,000 images, and it is difficult to just inspect this folder. So what we'll do, we'll move on to the next step. So the next step is to get the path of all the images stored inside this resized folder. We'll again check the length just to ensure all the images were copied successfully. So this matches with this one. Now we'll try to print some image paths. So for the first 5 images, the path is this one, like the name of the file is 6026, this and this. So it has randomly picked up 5 images from this folder, and then this is the complete path for those images. Now let's try to visualize this. So these were some, images that we had in our data set, just for our reference. Now the next step is to pre-process this image. So these images are not ready yet to train the model directly. We have to first pre-process it. And let's start with that. So what we are doing is, these images are nothing but some pixels, right? At the end, these are only some data that we get. So what we have to do is, we have to load these images in a NumPy array. Okay. we'll call it as train images. So it's a array of all those images, and we'll try to print the shape of the numpy array train images in this case. And you can see the shape of this numpy array is the size of the array. Okay, so it has this many number of images. It's 64 cross 64 in size, and 3 is the RGB channels. It's a colored image, you can see. Now the next step is to reshape this to again 0 cross 64 cross 60 cross 3. Okay, so if you don't do this, okay, if you don't do this step, this resize one, then you'll be need to doing this step. Okay, so because we have to reshape the images to this dimension 64 cross 64 cross 3. But just in case, I've just run this cell for my satisfaction, so that the images are of the correct size. Now the next step is to normalize the images. Okay, so when we talk about this, the generator model that will be generating the images, so the output it gives is between -1 and 1. It's a tan h function. If you just Google about tan h, it gives values between -1 and 1. So for that reason, we'll need to divide this by minus 127.5 and then divide it by this. So what happens when we do this is we get some values here in this case. Okay, so I've printed the value of the first image in the training set. Okay, and the value of that training image is this one. You can just give 5 or something like that, so it will give the values of those as well. So you can see these negative signs. This is because of the subtraction that we did in this step, and then after that we have divided that with 127.5. So that's the reason the value is always between -1 and 1. Otherwise, if you don't divide this, then the RGB pixels are always from 0 to 255. Okay, so 0 is extreme dark and 255 is extreme bright. So these are the two terminals. But since the function was, the activation layer was tan h, we need the value between -1 and 1 only, and that's the reason we did this. So everything looks fine at this step. Now the next step is to create the generator and discriminator models. Okay, since we are talking about DC-GANs, we'll need two models in this case. So as I started during the session, as I stated it, we start with a noise. Okay, so we'll declare a variable of size 100 for random noise. Then we'll initialize some weights using this function random normal. And of course, there are three channels for these images, RGB channels. So I'll run this cell as well. Okay, so let's visualize what's happening here. So if you go back to the repository that you had, cloned or downloaded, if you go into this generated folder, you will see epoch 000 image. Okay, and if you open this image, you won't find anything in this, right? It's just a noise. It's a random noise. You won't find any resemblance of any human in this. So this is the random noise that we start with. Now the next step is to define the architecture for this generator model. Okay, so there was the 1D random noise, and then we add a layer to this of size 8 cross 8 and 52, and then we give the input dimensions as the latent dimensions, this, yeah, that the noise that we had defined in the previous step. So this becomes the input in this case. If I go back to the slide, so we are at this step right now. Now the next step was to add layers and convert it from 1D to 3D, and then we'll keep on sampling it, okay, till we reach this 64 cross 64 cross 3. So this conv 2D transpose, this is nothing but deconvoluting a particular layer or particular image, you can say. Okay, with strides 2 comma 2 and this 4 comma 4, the weights will be as we had defined in the previous step. Okay, and then we'll just run this cell. So if you see the summary of this particular generator model, these are the parameters and these are the shape of each layer at each step. We start with this 8 cross 8 cross 512. So if you multiply these three numbers, you will get this shape. And then finally, we are receiving this 64 cross 64 cross 3 uh, output layer of this particular generator model. Now this thing will be given as an input to the next discriminator model. So let's define the architecture for discriminator model as well. So when we talk about this discriminator model, we'll just start with a sequential, layer. It's a discriminator with the input shape of 64 cross 64 cross 3, and then we'll give alpha as 0.2, then we'll add the layers as well. Now if you compare this generator with the discriminator, we had used conv 2D transpose, but in this case we are just using conv 2D. So this is convolution and that is deconvolution. It's a reverse. And after that we add some leaky relu layers as well. So leaky relu is nothing but it's a layer that you can just Google as well, that is used for for as a activation function. And then we run the cell as well. And finally, as you can see, the output layer for this discriminator was a sigmoid function. So it will give values between 0 and 1. 0 is fake image, 1 is real image. Anything between these two depends upon the closest proximity. If it is 0.1, then that is near to the fake image. If it is zero point 0.9, then that is real, close to the real image. Okay, now we have this models defined. Okay, now both of these models to work in sync, one after the other, will create a class DCGAN. Okay, it will take these as an input. It will take the generator model that we had defined in the previous steps. This will be input. Then the discriminator that we created in the previous step, that will be the input, and the latent dimension, that is the noise, that will be the third parameter. So noise, as I said, will be creating images from scratch. Okay, will be giving some random noise. Then there are some metrics as well to identify how the model is performing. So there will be two losses in this case. One is the generator's loss, okay, and one is the discriminator's loss. So we define this as the metrics, and then there is the optimizer here for this as well, for each of these generators and discriminators. Then we give the batch size for these images that we are going to provide. Now the noise, now that the losses generated by these two models, the generator and the discriminator, the overall the overall loss of this DCGAN model will be the average of these two. So if you just sum those two noise losses and then divided by 2, then you will get the overall loss. And then we start you know with the training. So during the training, okay, when the model gets trained, we'll have to see how the model is getting trained. So after every epoch there will be an image generated, as you can see. So this was an image generated after first epoch, this was at second, third, and so on. So for that purpose, we'll be monitoring how the DCGAN model is being trained. Okay, so this is the number of images that it will be generating. So, so it's 25 in this case, 5 cross 5. As you can see, there are 25 images in this case. And then we just run this cell as well. Okay, now in this line of code, as you can see, so after every epoch, the images will be generated inside this generated folder, but we don't have this folder yet. So we'll need to run this cell as well. What it will do is it will create an empty directory of folder called as generated. If you refresh this, then you'll see generated here being created. Next is we'll initialize this. So DCGAN is now ready to be trained. I will give the generator as the generator. So this is the parameter and this is the model name that we had created. So generator is the model name that we had created in this case, as you can see, this one. So it's always preferable to keep the parameter name and the name of the model same so that you don't get confused. And then the latent dimension as the dimension that we had given in the previous steps as 100. So we'll give this and run the cells. Now for each model to train independently, we'll define the learning rates as well. So for the discriminator, we have set it as 0.0001 and for generator as 0.0003. And the reason behind giving the generator uh, learning rate bigger than the discriminator learning rate is because if the discriminator trains faster than the generator, then it will just keep on discriminating between the images and the generator will not be able to generate any new images. So it's always preferable for the generator to to let it generate the images, and then whatever images were generated by this generator, that will be used as an input for the discriminator. So that's the reason we are training the generator faster than the discriminator. Okay, so we'll set this. Yeah, so this was the loss function as asked by one of the persons. So loss function is binary cross entropy in this case, and Adam optimizer is being used for this. Now this is the number of epochs. So if we train it for 50 epochs, then it will, take about less than 2 hours, I guess. And we don't want to train it for that period of time. So I'll just remove this and just keep it as 3 for now. That doesn't make any sense, but just for your understanding, I'll just run this so that it trains quickly. So the actual training begins in this cell once we have run this cell. Now with each epoch, you will see some losses being generated. So the discriminator loss is around something, and ideally this loss should decrease if we are, if we want to achieve some good results. So it takes some time. So for just 3 epochs, it is taking this much amount of time because we had about more than 22,000 images in our data set. And that also depends upon the data set size. So this is the image generated at the very first epoch. You can see it's complete random noise. We don't have any information in this image. So I'll just show you what will happen if you run it for 50 epochs. So this was the data set. Okay, this was the images generated by the model. So at 0th epoch it was this, after one it was this, and so on. So as I just keep on, going towards the right hand side, you will see that some patterns are being generated. You can see some, two eyes are being generated at each epoch. So these are the features learned by the model, and then if you go further, some human like images are being now generated. And this is how the, image looks like at the 49th epoch. So I won't say that, these images are very real, but still if we compare it from the very first epoch, we can see that these are the images. This somewhat looks like real if we just, zoom out this. Again, this image, you can consider it as somewhat real. I won't call it as completely real. Okay, so this was in this case. So in the second epoch, you can see some, some human-like faces are being generated. You can spot some eyes. If I just go to this generated folder, then these are the images saved inside this. So our model has been trained. Of course, this doesn't sound very good because this was trained only for 3 epochs. But just to show you how this is implemented, okay, you can always try it right from scratch. You can build your own custom DCGAN model and for different data set as well. So once the model has been trained, then we are good to use this model. Okay. So what we'll do is we'll refresh this and you will find this generator.h5 Keras model has been created. So this is the generator model that we are going to use. Now, if I run this cell, so the model will now generate new images every time I click on this. So it has given this as a image. Okay, of course not very good because it was just trained for 3 epochs. But if you increase the size of the epochs and if you just fine tune as per your requirements, then you will find some good results. And then finally, if you want to download your Keras model, then this line of code, it will download the Keras model here, generate.h5, and then the contents in this folder as well. So it will zip this complete folder, okay, for you, and then it will download this on your local desktop. So I already have this model. I won't run this. And that was it about DC GANs. So let's move on to the next subtopic of this session. So we are almost at the end of this session. So we'll see some more examples that are built with TensorFlow. Okay. So just for your understanding, I hope everyone have might played this game in your childhood. So TensorFlow is a tool, a powerful tool for machine learning that you can build many great applications for computer vision. So this is just one of the examples that I had worked on quite some time ago. So I'm doing a real-time object detection on the game called as GTA Vice City. As you can see, I'm playing the game at the left-hand side, and at the same time, the model is detecting some objects in the image. And this is one more fun project that I had built. So this is Ashes Cricket 2009 video game. So one day I was just thinking if I can just automate this process. So this is nothing but a post classifier based game controller. At the left hand side, I am holding my cricket bat and playing some cricket shots, and the same is being used by the model. Okay, so whatever output was generated by the model, I linked it to the video game using a Python script, and without touching the keyboards, the entire process was automated. And then finally, this Hindi character recognizer that I had worked on. So if you have heard about this MNIST data set, okay, it's a data set of characters and numerals from A to Z and 0 to 9 respectively. So it is only for English characters, I suppose. So just to take it a step ahead, so when I was learning this, when I was just starting my journey with ML, I thought, why not implement something that you have learned? So I just took it a step ahead and created my own data set for Hindi characters. I synthesized it. Okay. So since the MNIST dataset has features such as the characters will be white in color and the background would be black in color, and the size of each images will be 28 cross 28. So I synthesized the dataset in this format so that it resembles the original MNIST dataset, and then I applied transfer learning so that the same base model can be used for training the Hindi characters in a custom way. So that's about this session, and the reason behind showing all these projects was to let you know that these are the things that are possible with TensorFlow. If you can if you have some great ideas, then you can just go ahead and implement it and just share it in your circle as well. So that's a great point if you have just started your journey. That's how I had also learned when I started my journey with ML. So feel free to reach out to me by scanning this QR code. I'm on LinkedIn, and then you can also follow me on GitHub using this link. I also like to write some articles on the projects that I work on. So you can also follow me on my Medium handle using this link. So that's it from my side. We'll now take the questions and answers. I'll stop sharing.
So, well, that was a great session, and I really loved the examples which you gave. It was kind of nostalgic feeling seeing GTA Vice City and as well as a cricket game. So, thank you so much. So, let's move on to the questions. Is GAN only
No.
for images?
Okay,
Okay.
so no, GAN is not only for images. GAN is basically when we talk about GAN, it is generative adversarial networks, right? So GANs can also be used to produce text-oriented results. It's not only confined to images. It can be used for other variety of data as well.
So, is there any particular reason we use 64 cross 64 or 224 cross 224 image size?
There is no specific reason, I would say. So the reason behind using the 64 cross 64 was as you decrease the size of your input images, it becomes easier for the model to train. So if you compare it with the image of the size, let's say a very big image, an HD image of size 1600 cross 900, so it has a lot of data in that. And when we talk about training the model, it becomes very computationally expensive to train the model. So that's the reason we use this 64 cross 64. And even in the original paper it was implemented using this. So just to keep the relevance, in this case I had used this dimensions.
So the next question is, do we perform back propagation for generating noise?
Yeah, we do. You can also just create a random vector, okay, so that it generates the noise on its own. You can also do that as well, as we did in this code.
Why do we use leaky relu when we can get better results with relu?
So it's it's pretty experimental. It's always advised to use leaky relu, because leaky relu, as you can see, it doesn't it doesn't give image from 0 to 1. The value it is giving is from minus to 1. Okay, so in that case we make use of leaky relu instead of just relu, because the images that we were supplying, okay, the value was at the end, it was between minus 1 and 1. So that's the reason we use that.
We have one more basic question, like why does GAN take more time to train?
Okay, so when we talk about GAN, so there is one question from my side as well to the audience in this session. So my question to you all is, what kind of learning is this GANs? Was it a supervised learning or an unsupervised learning? Was I labeling the image data set? No, right. So when I started training the model, it was just a random set of images. Okay, it was just images that I was supplying. So it's a case of unsupervised learning, and that's the reason GANs take some more time to understand that these are the features within the images. And simultaneously, we are using two models instead of the old models, that in which case we are using only one model. So since here two models are in action parallelly, it takes time for the generator to generate the images, and then finally the discriminator will take the input and then find out whether this image is real or fake. So that does take some time, and that's the reason for that.
So why do we use DC GAN and when do we use style GAN?
So DCGAN is basically a basic version of GANs. Okay, it was introduced just to use the convolutional. If you remember CNN networks architecture, okay, so it was just a one step ahead of DCGAN. Now, when we talk about style GANs, so if you want to transfer styles from one images to another, so let's say you have two different type of images, and we want to merge them together to form a third type of image that has some features of both the images. And in that case, we make use of style GANs.
Okay, so I'll give one example over here, just in case. Now, suppose when we are training CNN model, right? Most of the time, when we have very less data, what procedure do we use? We use data augmentation. So
Correct.
DC can be used as data augmentation as well. Why? Because you are generating some fake images which are very similar to the image set we have. So once you have this kind of images, now you have double the size of your data set. So DCGAN will be better when you have image generation and as well as similar images, which will give you a better data size to train your model. And coming to the style GAN, if you are a gamer, right? Most of the time, what happens in gaming, you need multiple icons. Okay, so this is my character, this is my avatar. In order to create those avatars, in order to create a new design of characters, style GAN is used over those kind of examples.
So mostly if you're working on, if you're working some on arts or some, if you're trying to generate some picture, so style GANs is also preferable in that case.
Okay, so the next question is, I great learning for me so far. I would like to know what should be the optimal epoch to obtain good results, like any parameters we should consider for any type of data set.
So Ronnie, that is pretty experimental, I would say. It depends upon the data set that you are using. It's whenever you're learning something, it's we are preferable to start with some smaller epochs so that you don't waste your time in training something that will not be useful. And we also have to keep in mind that we shouldn't keep the epoch size very small, as I had kept in this case during the presentation or the session. So you could consider some numbers between 30 and 40 as an optimal epoch size. Additionally, it's advisable to read the papers before you implement anything, to understand what was implemented by the authors. So that will give you an idea about what needs to be adjusted, what parameters needs to be given.
Okay, so in this regards as well, for any parameters other than epoch, you should also try experimenting with latent vectors, like what kind
Right.
of noise you need to generate. So it's all about experimenting how well, what kind of parameters you're going to use.
Exactly.
And insightful session, sir. Thank you, Mr. Nitin. The GTA Vice City model was really cool.
Thanks a lot.
Thank you, sir. Great session. I enjoyed the application of TensorFlow used for cricket model. I guess there are no more questions, but we'll wait for 2 minutes. Any more questions?
Just in case, I'll put my LinkedIn profile as well in the chat. If you wish to connect with me, or if you have some great ideas that we can work on together, then feel free to connect with me on this profile.
Hi from Turkey. Thank you for joining this session. When did you start with TensorFlow, by the way?
Okay, so I'll just narrate my story shortly. So it was in my final year of engineering, where we had worked on a project that was focused on detecting waste from images. So we were working for this project, okay, and in that case we were trying to implement the object detection. So it's at that point that I started first, I first started learning TensorFlow. Then slowly I started exploring more in that field. I started implementing you know problems like image classification, then segmentation. So that was the starting point for me. And of course, if you want to start learning TensorFlow, so I'll recommend you a specialization on Coursera. So deeplearning.ai provides you TensorFlow specialization. So it will teach you right from scratch everything. What exactly are tensors? Some basic operations with TensorFlow. Okay, then it will take you a step ahead and in implementing TensorFlow for computer vision, for NLP. And then once you have learned how to train models with TensorFlow, the next step would be to deploy these models so that you can use these models somewhere. So it's not only about training the models when we talk about machine learning, it's also about how we are deploying that and how we are using that. So I would recommend this specialization if you are a beginner in this.
You do have that course on YouTube as well, the same deep learning course.
Yeah, right. You can avail that course on YouTube as well. But if you are looking for a certification as well, if you would like to add certificates to your profile, then you can just go ahead and enroll to that course on Coursera. Otherwise, if you are just looking for learning and getting some knowledge, then YouTube is always there for you.
I have attached your LinkedIn profile in the chat.
Okay.
So, any more questions?
Okay, I feel no more questions. Thank you
Okay,
so
I'll just
much, everyone.
summarize. Okay, I'll just summarize the DC GANs for just a minute, like what we learned in this session. Suppose you're working at any top companies, like suppose you are into a comic field, and your boss or anyone comes and tell you, okay, this is the character. I want a similar character to this. But now you are a person who don't know art, but you know how to generate an art using AI. So what you'll do first, you'll create a random noise of an image. So this is what a generator will do. And once generator, if you look at the model, right, the final layer at 64 cross 64 cross 3. Why? Because it is generating one image. Now this is a fake image. In order to discriminate whether it is a right image, real or fake, we use another model called discriminator. And in discriminator, we add a output layer which was sigmoid, either it is true or false. So, and that's the reason why we used binary cross entropy. And it is really very great to explore DC GANs, and not just GANs in particular, because the output you get, right, it is really very good to explore those things. So reach out to any of the speaker or AI Planet will be ready to help you guys. So till then, goodbye. Anything else you want to add?
Thank you so much for joining. Yeah. So Tarun, thanks a lot for inviting me and hosting me for this talk. I would also like to thank all the audience for joining this session. I hope you enjoyed this session as much as I enjoyed giving it. So I hope to connect with you all later in some time in the future. Thanks a lot again. Have a nice day. Bye bye.